Hi everyone, welcome back to the channel. If you're new here, my name is Micah, and this channel is dedicated to learning, teaching, and discussing everything about cybersecurity. So today we are back in TryHackMe, and we're doing the Sigma room. If you're not familiar with Sigma, Sigma is a open source generic signature language, and you can use that language to convert those detections that you write in Sigma to various SIEM backends. So for example, I could create a detection in Sigma and then convert it to KQL for or Custo query language for Sentinel, or SPL for Splunk, and so on and so forth. And this tool was introduced to me by Micah Babinski. I will link his profile down below, but he's been an awesome resource. I reached out to him on LinkedIn when I was trying to transition from the analyst role to the detection engineer role or field. And he's just been an awesome resource, been an awesome guy. So check him out. And without further ado, let's get straight into it. Okay, perfect. So I have my VM spun up, and this is not absolutely mandatory, but I like doing everything inside my virtual machine. And not sure if you can hear that, but I guess I have an Amazon package outside. Anyways, so let's get started. Let's actually add an hour to this because I started this a while ago and got distracted. Or not distracted. I was trying to get my setup correct. But anyways, so the introduction: detection engineering is an important role and task for a security analyst. It involves developing processes that will guide you as an analyst to identify threats before they cause any harm to an environment through the use of rules. This room will introduce you to Sigma, an open source generic signature language used to write detection rules applicable across different SIEM backends. So the learning objectives for this room is to introduce us to the Sigma rule language, to learn about Sigma rule syntax and conversion to various SIEM query languages, navigate through writing rules for the various detections on Windows event logs, and to practice writing Sigma rules for an interactive case. So some of the prereqs for this room are the security operations room. I'm not going to read all of these, but they're here. I highly recommend that you check these out before you start this, just so you have good foundational knowledge going into it. So task number 2. What is Sigma? So we've already kind of talked about what Sigma is. It's basically a format or a language where you can write these detections and then you can share these. It's open source. It's available for anyone to download and to use. And it was developed by Florian Roth and Thomas Patsky. I believe that's how you say his last name. And so it was developed to describe log events in a structured format. And this quick sharing of detection methods allows security analysts and detection engineers alike to share their rules and to basically add to the growing list and growing content of detection rules. That way you can easily implement them into your SOC or your SIEM infrastructure. So some of the use cases are to make detection methods and signatures shareable alongside IOCs and YARA rules, to write SIEM searches that avoid vendor lock-in, very important, to share signatures with threat intelligence communities, to write custom detection rules for malicious behavior based on specific conditions. So moving on along for the sake of time, now we're going over the Sigma rule syntax, and common factors to note about the YAML files are YAML is case sensitive. Files should have the .yaml extension. Spaces are used for indentation and not tabs. Comments are attributed using the pound character, and key value pairs are denoted using the colon character, and array elements are denoted using the dash character. And we can download the task files here, which gives us a template to use for the practical application portion. And you see I've downloaded it like 3 times already. So let's go ahead. So we have the title, ID, status, description, log source, detection, which is the meat and potatoes. We have false positives, level, tags, and basically go ahead and read through that. Just skipping through it for the sake of time, basically. And we're going to start right here at the search identifiers and condition expressions. So go ahead, pause the video, and then come back. So search identifiers and condition expressions. As mentioned earlier, the detection section of the rule describes what you intend to search for within the log data and how the selection and filters are to be evaluated. The definition of the search identifiers can comprise of 2 data structures, lists and maps, and they dictate which order the detection would be processed. So when the identifiers are provided using lists, like this example here, they will be presented using strings linked with a logical OR operation. Mainly, they will be listed using hyphens. For example, below we can look at the extract of this detection here, and is written to match on the host application field containing PowerCat or PowerCat PS1.ps1 as its value. So we're looking for this host application field, which contains either PowerCat or PowerCat.ps1. So searching for either of these two strings. So on the other hand, maps comprised of key value pairs, where the key matches up to a field in the log data while the value is presented as a string or numeral value to be searched for within the log. So maps follow a logical AND operation. Lists follow the OR operation, and maps follow the AND operation. So we have an example here, but I like this, or let's just pause right here for a second. I'm gonna switch over to this other blog post, which gives a really great example of the lists and maps. So in this first example, we have a list here. So in this example, search identifier 1 matches on evil service or service host.exe -n evil in the log line. So again, list is using this hyphen and is searching and is using the logical OR operator. So we have evil service or service host.exe, blah, blah, blah. And then down below here, we have a map, and you can see the key value pair. So here's the key, here's the value. And logically, this example reads event log equals security and event ID equals 4769, and so on and so forth. Like lists, you can create a list of maps. Lists of maps are joined with a logical OR. So we have the key value pair. So it's searching for the field where event log equals security, or event ID, and event ID equals either this 517 string or 1102. So logically, again, event log equals security and event ID equals either 517 or 1102. So hopefully that makes sense. And I'll leave a link to this blog post so you can read through the entirety. It is a really great example. So jumping back into TryHackMe, as an example, we can look at the clear Linux log rule listed below, where the selection term forms the map, and the rule intends to match on image pipe ends with either of the values listed, and command line contains either value listed. This example shows how maps and lists can be used together when developing detections. It should be noted that the ends with and contains strings or lines are value modifiers, and two lists are used for the search values, where one of each group has to match for the rule to initiate an alert. So again, logically, this reads image ends with either of these strings, and command line contains either of these strings. So as we have mentioned, the value modifier is worth noting that they are appended after the field name, again, contains or ends with the pipe character, and there are two types of value modifiers. So there are transformation modifiers. These change the values provided into different values and can modify the logical operators between values. They include contains. The value would be matched anywhere in the field. All this changes the OR operator of lists into an AND operation. Very important for the example coming up. This means that the search conditions has to match all listed values. So for example, if this said, we'll get into it. But so next is base 64. This looks at values encoded with base 64. Ends with this modifier, the value is expected to be at the end of the field. For example, this is representative of asterisk and then the string that we're looking for. So we're looking for everything before this string, and then starts with this modifier. We're looking for this. We're matching on anything that ends with this string. And then starts with this modifier will match the value at the beginning of the field. For example, we're looking for anything that starts with this string. So next is type modifiers. These change the type of value, or sometimes even the value itself. So currently the only usable type modifier is RE, which is supported by Elasticsearch queries to handle the value as a regular expression. So for conditions, which is here, this entry here, for conditions, this is based on the name set for your detections, such as selection and filter. So I believe you can just name these whatever you want to. And we'll determine the specification of the rule based on the selected expression. And some of the terms supported include logical and or, and we'll see a example down here below where condition is tools and filter, one slash or all of search identifier, one or all of them, and not. So an example of these conditional values can be seen in the extract below from the remote file copy rule, where the detection seeks to look for either of the tools SCP, rsync, or SFTP, and with either filters values at or colon. So logically, this is reading, excuse me, tools, we're looking for tools, field tools, and these values, so SCP or rsync or SFTP, and this string, this at symbol, or this colon. So, and the condition is tools and filter. So hopefully that makes sense. So to close out this section, we have an extract below from the run once persistent registry event rule, where the detection seeks to look for values on the map that start and end with various registry entries or values while filtering out Google Chrome and Microsoft Edge entries that will raise false positive alerts. So logically this reads, we have a search identifier here, selection, and saying we need both of these objects. So looking for the field that starts with this string and this field that ends with this string. One thing to note, so this will search for everything within the log file that we're searching within, because we're not specifying a field name like we are here. Just something to keep in mind. I just thought about. Sorry, back to it. So we're looking for this selection with target object that starts with this string, target object that ends with this string. And then we have another map here, details that starts with this string and details that ends with this string. And then we have a filter for edge, which is looking for this field that starts with either this string or this string, and details that ends with this string. This is all one string. And the condition here is selection. So we're looking for all of this and not any of this. Remember, we're trying to filter out the false positives. So that's why this condition says selection. So again, all of this and not one of these, not one of filter. That asterisk denotes that we're looking for anything that starts with filter underscore. All right, so here's the fun part. So the scenario is we are a SOC manager that have just received shared intel on AnyDesk, a legitimate remote tool that can be downloaded and installed silently on the user's machine using the file description on the right-hand side. And as a SOC analyst, we have been tasked to analyze the intel and write a Sigma rule to detect the installation of AnyDesk on Windows devices. So we have this intel sheet here, and we see that there's a bunch of process or command line execution. And let's go through the intel analysis. So the shared intel shows us a lot of information and commands to download and install AnyDesk. An adversary could wrap this up in a malicious executable sent to an unsuspecting user through a phishing email. We can start picking out the values that will be important for detecting any occurrence of an installation. So we have the source URL. This marks the download source for the software. This highlighted by the URL variable. We have the destination file. We have installation command. So we see cmd.exe being executed. Then we see some installation attributes like install, start with win, and silent. And then we have some other pieces of information from the intel, which is adversary persistence. We see that they created a user account, old administrator, and gave that user account elevated privileges to run other tasks. And then we have a registry edit as well, where the added user is added to a special accounts user list. So we're going to use all of this information to build out a detection in Sigma format. So since we've already gone through much of this creation activity or the syntax and whatnot, I'm just going to copy and paste each of these excerpts into a file, and I've already done that here. So we have the detection, we have selection, we're looking for command line, the field command line that contains all. And remember, the transformation modifiers modify how these act. So instead of saying or, as notated by this hyphen, this is an and. So we're looking for all of this. So install this string install and start with when. And current directory, the field current directory that contains this string here. And our condition is we're looking for all of this. So scrolling on along, we have two methods to convert our rules into our, I believe, Elastic query format or syntax. And SIGMAC is a Python written tool that converts Sigma rules by matching the detection log source field values to the appropriate SIEM backend fields. So this would be deprecated or has been deprecated already. And the replacement is the Sigma CLI Python script or program. And you can read more about that with a quick Google search. But we're going to be using uncoder.io. It's an easy open source web Sigma converter for numerous SIEM and EDR platforms. And it's pretty easy to use, pretty straightforward. So I'm just going to copy and paste what I copy and pasted from these code blocks here, this one and this one. I put it into this file here. I'm copying the detection that we created, and I'm going to paste that into uncoder. So let's do that now. So as you see, I've already done this. I can do it again, copy, paste. Then we're going to choose Elastic Query because that is the language that we want to convert it to. And we have a tip here: be aware that the converted queries may not work verbatim as converted from the tools. And this is due to the processing of the regex characters. We have a backslash and an asterisk, and you may be required to adjust the queries, especially around escaped blank space. So for example, this exercise, you have to remove the asterisk characters from the result and only escape the colon in the folder path and the directory slashes. So we're going to be escaping the colon and the directory slashes from this output here. So let's go ahead and copy this. And that will make more sense once we get into the actual Elastic instance. Let's look for the password for this thing. Let's copy that. And the password is THM analyst 1234. So 1234. So copy that. Wait for that to load. And then we have to change the time filter. So I'm gonna do like 5 years ago, just to search for everything. And we're gonna paste in that query that we converted. So remember, let me make this bigger. We're gonna remove the asterisk, remember, and then we're only gonna escape the colon and the backslashes from the directory path. So let's remove this. And then we're escaping this colon character here with this backslash. And then we should be able to run this and get some results back. Perfect, and that worked. So already you see the power of Sigma. You can create a YAML format, it's a generic template, and you can convert it to pretty much anything that you want. Let's go ahead and try to convert this to like SPL. So we have SPL here now. Make that bigger. What else do we have here? I mean, this is a pretty cool tool. Let's try like Sentinel query. I mean, pretty much flawless. You might have to do a little bit of tweaking like we saw just now, but I mean, it works. So let's go ahead and answer these questions. So I believe I can expand this with this. So full screen, and then I believe autofit. Yep. Okay, cool. So actually, I won't answer these questions, but if you're following along, you should be able to easily answer this with this log output here. So moving right along, we have the next task, which is SecOps decisions. And basically, this is just going over the different options that you can use with SIGMAC And we didn't use Sigmac, so I'm not going to worry too much about it. Feel free to stop and read and follow along afterwards. So this is the last task. We are actually in the practical scenario, and we are almost done with this room. So I'm very excited. Hopefully you are too. So the first question: to detect the creation of the scheduled task, what detection value will be appropriate for the Sigma rule? So we know we're looking for scheduled task. It is a executable that's located in the Win32 or system directory rather, and the name of the executable is this as follows. So let's copy this, and the hint says to include the backslash in the answer. So backslash and then our executable. All right, so I believe the rest of these questions require us to go ahead and create our detection. So using the tips and information above, I went ahead and created 2 queries in Sigma or in Uncoder using the Sigma YAML format. And so we have the scheduled task creation. I left out some of the optional fields just to make it look a little bit cleaner. So we're detecting scheduled task creation. Remember, we're using image and the command line. So we're looking for scheduled task.exe, and we're looking for the command create. And this was all found via Google and Microsoft documentation. And we're filtering out the user, the entity authority system user. So logically, this reads selection image or command line. I'm sorry, image and command line, because we're key value pairs, and filter the user entity authority system, and we're filtering, or our condition is selection and not filter. So we want all of this and not this. So let's go ahead and translate. And one thing I noticed, something to note, I believe that using the @ sign as your author, it won't allow you to translate rules. So just something to think in mind if you're banging your head against the wall trying to figure out why your thing's not working like I did. That's probably why. So go ahead and translate that. So I'm going to copy this, and we want to change our time filter to at least a year ago. I'm just going to do 2 years just to be safe. Okay, so I just realized I had the wrong translation for my query. So I changed it to Elastic Query, and we're going to try this again after like banging my head on the wall, wondering why it looked like SPL and why it didn't work. So, okay, let's try this again. We're going to remove the asterisks, and we are going to escape the colon, and escape the backslash, remove asterisks, escape the colon, and I believe it doesn't like double quotes. That is just perfect. So does this look good? I'm not sure we have to escape this. We'll do it anyways. And it can scream at me if it wants. Oh, we have to escape this as well. Oh my gosh. I'm missing something. What am I missing? Maybe I don't need to escape these. Oops. Boom. So you don't have to escape the colon, I guess. I don't know. Whatever. But that seemed to work. It seemed to like that. So let's go open this up full screen. Pop these out to autofit. And we can get our information, our answers here. What is the name of the scheduled task created? Looks like spawn. What time is the task meant to be run? 2010. To detect ransomware activity, what log source category would be appropriate for the Sigma rules? So we're looking for, I think, file creation. I have it written down right here. File event. Okay, so here is our ransomware detection, and we are using the transformation modifiers ends with and contains. And let's translate this into Elastic, and let's copy it. So we're looking for an image that ends with cmd.exe, and the command line contains .txt. And make sure that your time is correct 2 years ago, and this should work. Awesome. So we found our ransomware event. All right, so we have our .txt file here. Copy that, paste that here. What event code was associated with the activity? Just look for code, maybe. Nope. So file creation, file creation event code 11. That worked. Yep. So what were the contents of the created ransomware file? So what is its contents? Let's see here. Blah, 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 blah. Oh, so we're echoing this message into this text file. So this is our answer. Awesome. It looks like we are done with this room. And then they included a Sigma syntax cheat sheet at the end. Not sure why this wasn't before, but either way, we are done with this room. So quick recap, we learned about Sigma, we learned what it is, we learned about the Sigma syntax, we learned how to convert or how to translate a threat intelligence report into a functional detection. We learned about converting Sigma rules from that YAML format into various SIEM query languages. And then we used our newfound knowledge in a practical application with the ransomware event and the file creation event, or the scheduled task event. And I think it was pretty successful. Had some headbanging trying to convert and tweak the queries a little bit, but it wasn't too bad. Anyways, if you like the video, please like, leave a comment, subscribe. Please follow me on LinkedIn if you so choose. I would love to hear from you, chat. And that's pretty much it. I hope you have a blessed one, and I'll see you next time.